This is page 2 of the review for your upcoming test on fraction operations and probability. In problem number 5, we're subtracting two mixed numbers. I have 7 2/3 minus 4 4/5. First, we need a common denominator for these fractions, and the common denominator would be 15. So 2/3 multiplied by 5/5 is 10/15, and 4/5 multiplied by 3/3 is 12/15. So I can rewrite this expression as 7 10/15 minus 4 12/15. And I can subtract 4 from 7, no problem, they're like terms, but I can't subtract 12/15 from 10/15 without getting a negative fraction. I'd like to avoid that. So I'm going to borrow some 15ths from these 7 wholes. If I just borrow one whole, making this 6, I've just borrowed one whole, that's 15/15. So I have 10/15 and 15/15. So that's 6 25/15 minus 4 12/15. 25/15 minus 12/15 is 13/15. And 6 minus 4 is 2. So 2 13/15 is the final answer for that problem. Problem number 6, Melissa's recipe for rye bread calls for 3 3/4 cups of white flour, 5 2/3 cups of rye flour, and 2½ tablespoons of butter. How much flour is used altogether? So if this word is the key that we're adding the cups of flour. So that would be 3 3/4 plus 5 2/3. The 2½ is not part of this problem. It's extra information that we don't need. We can turn fourths and thirds into twelfths, the LCM of 4 and 3. We can turn fourths into twelfths by multiplying by thirds. So we need to multiply by all 3/3. And 2/3 multiplied by 4/4 will give us twelfths. And so this is equivalent to 3 9/12 plus 5 8/12 for a total of 8 17/12 cups of flour, but we don't want to leave this fraction as an improper fraction. There, I'm going to rewrite it as 8 12/12 and 5/12, because 12/12 and 5/12 is 17/12. Essentially, you're seeing how many times 12 goes into 17. It goes in one time with a remainder of 5, but that 12/12 represents one more whole, so 8 and 1 is 9. And so the total amount of flour is 9 5/12 cups. A box contains 6 different color paper clips. The box contains 3 red paper clips, 4 yellow, 5 green, and 6 blue. What is the probability of reaching into the box and selecting a red paper clip? So we know that probability is the ratio of favorable outcomes to possible outcomes. There are three red paper clips, so there are 3 favorable outcomes. And the number of possible outcomes would be the total number of paper clips, which is 6 and 4 is 10, and 5 and 3 more is 8 more, so 18. So 3/18 would be the ratio, and that would simplify to 1/6 probability of selecting a red paper clip. The next part of the question asks, what is the probability of reaching into the box and selecting a paper clip that is not yellow? We know the total number of possible outcomes is 18. There are 18 paper clips in the box. We could add up all the ones that are not yellow, but just as easy would be to see that there are 4 yellow. So that must be 18 minus 4, or 14 that are not yellow. And 14 and 18 have a common factor of 2. So if I divide both numerator and denominator by 2, factoring 2 halves out of that expression, I get 7/9 as the probability of reaching in and selecting a paper clip that is not yellow. The next part of the problem says, what is the probability of reaching into the box and selecting a blue paper clip, then putting the blue paper clip back in the box, then reaching into the box and selecting a red paper clip? So The probability of picking blue would be, there's 6 blue, so 6/18. And the probability of selecting red we've already calculated up here is 3/18, or in simplest form, 1/6. And the probability of those things happening one after the other is equal to the product of these two probabilities. The reason the red probability of choosing red was not influenced in any way by the fact that I chose blue, because it told me that I put the blue paperclip back in the box before reaching in to try to select the red. So we could multiply, but I see there's a common factor of 6 here with these two 6s. So these can both become 1s, and we get a product of 1/18. That's the probability of selecting blue then red with replacement. Were these last two events independent or dependent? The second event, the probability of selecting a red paperclip, in no way depended on us picking a blue first, because the blue was placed back in the box, and we randomly selected a paperclip after that. So these are independent events, since the blue paperclip was replaced. Last problem on page 2. Consider the equation A divided by B equals C. So the quotient of A and B is C. If the dividend A is decreased, what is the effect on the quotient C? First, let's just think about what division is. Another way of thinking of A divided by B is, you could say, how many B are in A? Not 8A. How many of B are in A? And that tells you what C is. Another thing we could do is actually use numbers like 16 divided by 2 equals 8. So we give values to A, B, and C and see what happens if we increase one or decrease the other. If the dividend A is decreased, so if we're trying to think of how many B's are in A, if A is decreased, there's fewer B's in A, right? I can't fit as many B's in A if A is decreased. So that must mean that C is decreased. So I think the effect on the quotient is decreased, but let's actually try it with the numbers. The dividend A is decreased, so instead of 16, let's make A 8. 8 divided by 2 is 4. So yes, C would be decreased. So if A increases, C decreases. If the divisor B is increased, what is the effect on the quotient C? So let's go back up to this statement. If this divisor is increased, so if we're asking how many B's are in A, if B is larger, shouldn't there be fewer B's in A if B is larger? So C again should be decreased, I think, looking at that statement. But let's go back to our original equation. 16 divided by 2 is 8, and let's increase B. So instead of 2, let's make B 4. 16 divided by 4 is 4, so yes, C is decreased from 8 to 4. So when B is increased, C is decreased. The quotient is decreased. This third part says if the quotient C has increased, what might that tell you about either the dividend A, the divisor B, or both? So if C is larger, if we're asking how many B's are in A, if B is smaller, there are more B's in A, so C would be larger. Or if A is larger, I can fit more B's into A. And so when B is smaller or A is larger, when B is smaller or A is larger, then C is larger. So either A increased, B decreased, or both. Both A increased and B decreased. If you were choosing A and B in an attempt to minimize C, what types of value might you choose? Well, we know that C is decreased when I increase A. I messed up here. You guys may have noticed this. much earlier than I just did. This should say when A decreases, C decreases. Okay, so if I'm trying to minimize C, I'm either going to decrease A or increase B. So I want small values of A, the divisor, or large values of B, the dividend. I just messed up my vocabulary. Let me fix this. Let me write it down here. A is the dividend. You either want small values, you either want a small dividend, and that's A, or large divisor, which is B, or you want both. Okay, that completes page 2 on the video. We'll continue the review with page 3 on the first problem on page 3 on the next video. Thanks for watching.